Hello students, in this topic we are going to discuss about the mass defect and the binding energy. Mass defect, the name itself seems to be strange, right? Yeah. So let us see what is meant by mass defect. You already know that nucleus is made up of protons and neutrons. So if I take the total mass of protons and the total mass of neutrons and add them both, you should get the mass of the nucleus. Am I correct? Because nucleus consists of protons and neutrons. So if I add mass of protons and mass of neutrons together, I will get the mass of the nucleus. I should get the mass of the nucleus. But when we calculate, the mass of the nucleus will be slightly lesser than the sum of the masses of protons and neutrons. That difference in the mass is called mass defect. So what is meant by mass defect? It is the difference between the rest mass of the nucleus and the sum of the masses of nucleons composing a nucleus is known as mass defect. I will write like this: delta M. Delta M stands for mass defect. Delta M is equal to Z into MP. Z is the atomic number, MP is the mass of the proton. So Z MP is the total mass of protons, plus A minus Z. A minus Z is the number of neutrons into Mn, mass of one neutron. So A minus Z into Mn is the total mass of protons, total mass of neutrons. So ZMP is the total mass of protons and A minus Z into Mn is the total mass of neutrons. I added both and I subtracted it from M. M is the mass of nucleus. Okay, mass of nucleus is lesser than this quantity. That is why I subtract this minus the mass of the nucleus. That is called mass defect. Mass defect per nucleon is called packing fraction. Mass defect per nucleon is called packing fraction. So why this mass defect has come? During the nuclear formation, some of its mass, some amount of the mass is converted into energy according to the equation E is equal to mc square. That energy helps to bind all the nucleons within the nucleus. Okay? During the nuclear formation, some mass is converted into energy. That energy is used to bind the nucleons within the nucleus. That is called binding energy. So that is the reason why this mass defect happened. Some matter is converted into energy. So let us see that. So that is the physical significance of mass defect. Now let us see what is binding energy. So I already told some matter is converted into energy. That energy is used to bind the protons and neutrons within the nucleus. So binding energy is defined like this: it is the energy required to break up a nucleus into its constituent parts and place them at a infinite distance from one another so that they will not come back. So why I am making the definition like this? I should easily say that binding energy means the energy required to bind the nucleons within the nucleus. Why I am not saying that? That is an attractive force. So the energy will be negative. When we say the definition will be along the positive value. So that is why we are saying if that energy is negative, if I give an equivalent amount of that equivalent amount of energy will separate the nucleons within the nucleus. So that is why I made the definition like this. So binding energy BE is equal to delta M into C square. So delta M, we already know what is delta M. So here I will be writing, instead of delta M, I will be writing Z into MP plus A minus Z into Mn minus capital M, mass of the nucleus, into C square. This is the expression for the binding energy, and this energy you will get it in joules, but we are not expressing binding energy in joules. We want to express the binding energy in mega electron volt. So what should I do? Divide this equation or divide this answer by 1.6 into 10 raised to minus 13. So you will get the answer in mega electron volts. Okay, so that is all about the binding energy. Now let us see what is nuclear force. Nuclear force is the force which binds the protons and neutrons within the nucleus. So we already studied nuclear force is the strongest of all the force in nature. The strongest force that we know is the nuclear force. So nuclear force is the force that binds the nucleons. It is the force that binds the nucleons within the nucleus, and it is the strongest force in nature. So let us see the properties of the nuclear force. So first one I told, it is the strongest force in nature. When I compare the nuclear force with the gravitational force and electrostatic force, I can just say like this: Fg gravitational force, Fe electrostatic force, Fn nuclear force, 1 is to 10 raised to 36 is to 10 raised to 38. So you can see this is very much powerful than the gravitational force. Gravitational force is the weakest of all the force in nature. Now number 2, they are short range forces. They are short range forces. What is meant by short range force? The nuclear force will only act in the nuclear distance. If the protons and neutrons goes out of the nucleus, there is no nuclear force. So nuclear force only acts within the nucleus. That is why we say they are short range force. That means they act like around 2 to 3 Fermi meters, only in this distance, only till this distance, 2 to 3 Fermi meter, and after 3 Fermi meter there is no nuclear force at all. Okay, that is the second point. And the third point is they are charge independent in nature. They are charge independent in nature. So what is meant by charge independent? We already know protons are positive charge, and if I ask you protons and protons will attract or repel, you will say repel. That is the electrostatic force of repulsion. Okay, but when the protons and protons comes in the nuclear distance, they are not considering the charge. If the protons and protons are coming within the nucleus, they will attract only. They will only attract. Similarly, neutron and neutron, there is no attraction, right? Because they are no charge. But when it comes within the nucleus, they will attract. That means there is a force of attraction between a proton and proton pair, a proton and neutron pair, and a neutron and neutron pair. We are not looking about the charge. Okay, we are not looking about the charge. There is a force of attraction between proton-proton pair, proton-neutron pair, and neutron-neutron pair when they comes within the nuclear range. That is why it is called charge independent. Now, the fourth property, they show saturation effect. That is the fourth property, saturation effect. What is meant by saturation effect? Saturation effect means a nucleon can interact only with the neighboring nucleons. For example, imagine 5 nucleons are like this. This nucleon and this nucleon will have an attraction force. The second and the third nucleon will have attraction force, but the first and the third will not have any attractive force. First and third will not attract. Similarly, first and fourth, no attraction between the first and fourth. Now, between second and fourth, no attraction. So, there will be force of attraction only about the adjacent nucleon, not even about the nearest neighbor, not even above that neighborhood, just the adjacent neighboring electron, neighboring nucleon. Okay, a nucleon can interact only with the neighboring nucleon, not even to the next nucleon. That is called saturation effect. Now, the fifth point, they are non-central forces. They do not act along the line joining the center of two charges. So, they are non-central force, they are short range force, and they do not obey inverse square law. So, those are the properties of nuclear force. Now, if we draw a graph connecting the potential energy of a pair of nucleons with the distance, variation of potential energy of a pair of nucleons with distance. If we draw a graph related to potential energy and distance, the graph will be like this. This is the potential energy. It is given in mega electron volt. So, I mark here minus 100, 0, plus 100, plus 200. Now, the distance I am marking it in Fermi meter. Distance is R is marked in Fermi meter. So, 1, 2, 3, 4. We told nuclear force will act only up to 2 to 3 Fermi meter. Above 3 Fermi meter, there is no nuclear force at all. So, there is no force of attraction means there is no force of attraction means there is no energy, no potential energy. So, the potential energy is 0 after 4 Fm. So, when I draw the graph will be like this. The graph will be like this. There is no force of attraction at this point, and then the force of attraction will increase after this one, and when it reaches here, the force of attraction becomes maximum, and soon after that it will become like this. So, when you draw the graph, you will get the graph of this shape. Here there is no force of attraction, and after 3, below 3 slightly force of attraction is happening, and force of attraction is maximum at this point. This point is around 0.8 fermimeter. 0.8 fermimeter, the force will be maximum, attractive force. And again, if they try to come closer, the force will be strongly repulsive, so that they can't come closer again. Every nucleon can come closer only up to 0.8 FM. If they again try to come closer than that, the force will be strongly repulsive, so that they cannot come. That is why the nucleus is stable. Otherwise, you just think what will happen, they will come closer, and finally they will collide and the nucleus will be destroyed. That is why the nuclear force is designed like this. So, this shows the force of attraction, and this shows the force of repulsion. The positive potential energy. The positive potential energy shows the force of repulsion, and the negative potential energy shows the force of attraction. So, that's all about the nuclear force. Thank you.